Here we are again, another set of wireless earbuds on our teardown table and another PSA. Most earbuds are disposable electronics destined for the e-waste stream, assuming they don't catch fire first. This time around it's Sony's WF-1000 XM6 earbuds. Over the years we've watched in disbelief as Sony took the highly repairable XM3s and nerfed them to the point where you'd need a rework station and micro welding equipment for what used to be a simple battery replacement. Now with highly repairable options like the Fairbuds on the market, has Sony finally upped their game with the XM6. Before we dive in, we have a chance to examine the CT scan provided by our friends at Lumafield. The results are a bit of a mixed bag. Take a look at the buds. It's clear that everything is glued in, there's not a screw or clip in sight. But a closer inspection of the battery reveals a positive development, 2 spring finger contacts that tease a potentially removable battery. Now with that in mind, we need to take the good with the bad. The battery case for the XM4 and XM5 both had easily removable batteries that used JST style connectors, yet somehow despite having plenty of space inside the case, Sony decided to revert back to the XM3 style soldered connections for the battery. I'll need to open up the buds in the case to confirm these observations, and I'm going to start with the buds. Unless you've got something like the Fairbuds or the Sony WF-1000 XM3, you'll need a rework station or other heat source to get inside most earbuds. To my pleasant surprise, the XM6 needs less heat than most earbuds I've worked on. I think you'll have a fair chance of opening these with just a hairdryer. Here's another pleasant surprise. The capacitive touch layer that pops away uses spring finger contacts, which is great from a repairability perspective. The fewer delicate flex cables I have to deal with, the less likely I am to damage anything during disassembly. From here I can see both the external facing MEMS microphones bracketing the SIP or system in package in the center. The SIP itself is connected through a press connector and comes away with very little force. So far so good. This level of modularity is excellent from a technician's perspective. The remaining flex cables are glued to the battery and a little isopropyl alcohol is enough to pry the delicate cables away. Underneath that I can see that the battery is indeed connected through these 2 spring fingers, which means there's no welding involved in securing the battery, just some stubborn glue that does eventually give way. Having both positive and negative terminals on the Zenithpower Z55FA battery is unusual, suggesting the 366 mWh battery is a custom order design based on the similarly sized 347 mWh Z55FH used in the XM5. With the battery out and my questions about repairability answered, there's really no reason to risk damage to the internal components which are not designed to be removed. Now let's take a look at the case, and as with previous generations, the case is held mostly in place by clips. I did use a little too much force and damaged the corner of the case, so definitely be gentle with the plastic if you're trying this yourself. Once the clips are released all around, I can pull the outer tray away. Underneath the case is the wireless charging coil and, as we saw on the CT, the battery is soldered in. To get to it, I need to move a section of the copper coil wiring out of the way. Popping the plastic clips around the battery tray also releases the half of the tray that has the battery attached. I'm going to go ahead and unscrew the other half of the battery tray too, along with the PCB underneath it, just to make desoldering the battery wires from the PCB easier for myself. It's worth noting again here, it's perplexing to see this regression when the last 2 generations of these earbuds and even the over-ear WH-1000 series are now all using JST style connectors that allow for solder-free battery replacements. In the past we've heard decisions like this can come about when engineering teams change or there's a lack of communication between teams in a large organization. Whatever the reason behind this decision, for these earbuds, it turned into an unnecessary ding to repairability. Another failure point on all devices are the ports, the USB-C charge port in this example. It's always a good idea to have some form of modularity here to make replacements easier, something that's lacking in this design. As for the rest of the case, there's not much more here other than a couple of intermediary PCBs, one housing the spring contacts that charge the buds. I really couldn't be more conflicted about these buds. On the one hand, I just performed a non-destructive teardown and reassembled the device in fully working order. This proves that a moderate level of skill is enough to perform these repairs, well within the means of many of you. But on the other hand, the unnecessary use of glue in place of clips continues to plague most in-ear wireless buds, including these ones. Then there's the inexplicable decision to solder the charging case's battery instead of using any number of suitable tool-free connectors. This by itself ups the ante in terms of gear and skill required to replace the battery in the charging case. What's worse, it was a problem that was already solved in both the XM4 and the XM5. As for manuals and spare parts, at release we weren't able to locate either, but a quick look at the Right to Repair manual speaks volumes of Sony's approach to repairability. For the XM5 they include a short troubleshooting guide where both the buds and charging case are labeled as unrepairable. It's with all this in mind that the Sony WF-1000 XM6 earns a repairability score of 3 out of 10 on our wireless earbud repairability scale. This could have been a middle-of-the-road 5 out of 10 if Sony offered useful spare parts backed by real repair manuals. Don't get me wrong, I'm sure the performance on these buds are great, but until repairability catches up, I just don't think they're worth the $330 price tag.